All right, here's the player right down here, P. See the letter P? If I'm going to move him from his current position, he's going to move. If I move to the left, he should show up right there. So I'm going to do L and enter. And oh, somehow I did something wrong because I just teleported all the way up here. I must hit the wrong key. Let me go up again. U for up because I want to wrap around the screen. There we go. Well, now I'm here. I don't know what I just did with that first move I moved down. I really want to go L for left. Let's see here. L, enter. There we go. L, enter. L, enter. L, enter. So now in this position where I am, if I go to step left, he's going to move off to a negative value, and I want to teleport him over to here. So I'm going to do L, enter. And it teleported me over here. The way I did that is I'm always testing what's that next box I'm about to go to. If it's less than 0, I want to add the size of the grid, whatever that is, that dimension, 6 or in this case 10. What questions do you have about that? So the math is as hard as this. Remember, the people say there's a lot of math in programming. Can you do math like this? So now we're going to try this version where we're doing the number 6, and I'll show you how that comes into play. It's really quite simple, I hope. What I'm really trying to do is give you simple examples like 0 and 1 because they're achievable and understandable numbers, whole numbers, because fundamentally, if you get the fundamentals down, we can deal with bigger numbers later. I just want to make sure we have the right understanding with a very small set of numbers right now. What we're going to do now is we're going to take a look at the code again using the example that I want to step on number 6. So I'm going to draw, actually I'm going to erase a little bit in here. I was going to say I was going to draw in here, but I'm always going to see how many times does 6 go into the value, and I'm always going to come up with some kind of a quotient and some kind of a remainder. So this is the size of the world, and I'm always going to use the size of this is going to be MOD, or the size of the grid, and this one over here is going to be where we're going to be putting the value of the next box that we go to. That's how you set up your math to actually calculate this. So that measure is always going to be 6, and what's the next box we're going to? The math that we're actually going to do in our program, and I'm going to exit this by doing E-enter to exit. I'm out of that, and I can take a look at the code again. So remember, this is only true if we go to step off of the playing field to a -1. Otherwise, what we do is we do this one thing here. A return statement is going to return an integer value, which means calculate a number, a whole number, and give it back as the spot where the player is going to step. Now, when they try to step on a number, we're going to say, all right, let's move that into a little location and let's try. Can they step there or not? And this little calculation here will figure out, can they step there or not? What it's saying is divide the size of the playing field into that next box and give me the remainder. So here's the deal. If I go to step on 6, then my next box would be 6. So here's the 6 I put in there. 6 divided by 6 is what? We went through this one earlier, but this time I want you to see what it is. 6 divided by 6 is 1. So the answer is going to be 1. 1 times 6 is going to be the 6 that we're going to calculate out here. We're going to do our subtraction. And 6 take away 6 is going to give us 0. So when they try to step on 6, we're going to give them a remainder of 0. We don't give them 1. We give them the remainder. So what does that mean? If they go to step on 6, we're going to put them on 0. So let's look at our picture with Frogger again. So if they go to step on 6, I'm going to change colors here. If they go from 5 and they try to step on 6, because this would be 6, it's going to say, what's the remainder of 6 divided by 6? It'd be 1 with the remainder of 0. So the 0 is where they would go. So they go to step on 6, they would get teleported over to the remainder spot, which is 0. Yeah, that's a head scratcher. That's a head scratcher. If I'm on 5 and I go to step on 6, it says 6 divided by 6 is 1 with a remainder of 0. I'm going to put you on 0. Now, there's nothing on the code that says if it's negative or if it's above 6. It does the same math every time. So what does it look like if you're somewhere like, I don't know, let's say you're here on the second lily pad and you wanted to step on the third lily pad? First of all, can you step on lily pad number 3? Is that solid? Can you land on it? Yes or no? Do a poll here. Can you land on 3? Is it a valid lily pad on the playing field? So, can the player land on lily pad number 3? Valid spots are 0, 1, 2, 3, 4, and 5. Is 3 in the set of 0, 1, 2, 3, 4, 5? So I'm trying to get as many people to respond. And if you don't, if you want to say no, say no. So I'm trying to figure out, can I land on number 3? If I'm on number 2 and I move over by 1, what could I do this? All right, so I'm going to publish the polling results. Everybody that answered said yes. Obviously, I should be able to move from 2 to 3. That would be fine from 2 to 3. But what does the math look like there? Because the same calculation is going to happen. That same algorithm. So let's take a look at what that looks like in our little math layout, because we can use it again. We can just clear out these values that we used. So we were on 2, and our next box, if we're going to step over, is what? What's the value we're going to step on? If we're on 2 and we're going to step on 3, we're saying next box is 3. How many times does 6 go into 3? How many times does 6 go into 3? No decimals here. And I can have a remainder, okay? So let's think of it this way. If there's 6 people in the room, all right? Let's go to purple. If there's 6 people in the room and I have 3 slices of pizza, how many pieces of pizza is each person going to get? How many whole pieces of pizza are you going to get? We'll try that again. And it's okay to say, I don't know. How many whole pieces of pizza are you going to get? There's 6 people and 3 pieces of pizza. How many whole pieces are you going to get? I'm going to stop sharing my screen so we can get our polling numbers in there. And we've got 9 people that understand that if you're going to share them equally, you're not going to be able to have enough for each person to have one piece. So 0 is the answer I'm looking for. Because if I give a piece to one person each, there's not enough to go around. So we'd have to give people parts of pieces. So the answer there really is 0. We can't give everybody a piece. So 0 times 6, 0 whole pieces gets used. What's our remainder that we have? 3 take away 0 is... So 3 take away 0 is what? I had 3, and I'm going to take away 0. How many do I have left? A couple of people haven't responded. I'm going to publish those polling results. So if there was 3 and I take away 0, how many do I have left? I should still have 3 because I took away 0. That would be considered a remainder. If I have a remainder of 3, that's the number that I'm going to be returning. Here's the magic thing. When you run through this formula, if you come in and you say, I've got 3, the result is going to be 3. Because you can't divide 3 equally by 6. So this next box is always going to return the same number, except when the number is 6, and then it's going to return 0. So let me ask this question with a different move. I'm going to go back into the other paint picture. All right, so we just went through a scenario where the player went from 2 to 3. What if we actually had the player on 1 and we wanted to move over to 0? First of all, can I move to location 0? Is that a valid spot, a valid lily pad? Can you land on that spot? Can you land on 0? So this is a scenario. You're on 1 and you want to move over to land on 0. So let me go back to the poll again. I want to ask again with that new description. Can you land right there on position 0? So in this world, it would be that the player's on number 1 and they're trying to move to position 0. Does that seem like that should work? I'm on 1 and I want to move this way and land on 0. Is there a lily pad there? Can I land on 0? I think I should be able to. So let me go back into my screen again. So what happens is if you try to land on 0, the code is basically going to say now your next box is going to be 0. And the first thing that's going to happen is the code's going to say, is 0 less than 0? So right here, it's going to say, if 0 is less than 0. Is 0 less than 0? Is 0 less than 0, or is it equal to 0? So is 0 less than 0? No, it's not. It's not 0. It's not less than 0, I should say. So it's not going to do this next line. It's not going to add 6 to it. Instead, it's going to say take 0 and figure out what the remainder is. If you how many times can 6 go into it? So we're going to take 0 and divide it by 6. Now it's in this order, but when we do the math, it's going to be how many times does 6 go into 0? And what's your remainder? So can you put 6 into 0? Nope. 0 times 6 is 0. 0 minus 0 is a remainder of 0. So the remainder that gets returned is 0. So if they try to step on 0, it's going to return 0. So it works for 0. So let's try another scenario here. I'm going to clear all my annotations. I think that was getting a little messy. Let's put our lily pads back in order here. 0, 1, 2, 3, 4, 5. There's 6 of them all together, but the numbers start. Let's see here. Pen, ink. Remember, we have positions. Ooh, that's way too big. Remember, we have position 0. We have a 1. We have a 2. We have a 3. We have a 4. We have a 5. But we do not have, we can't step into the street because we'll get splat-oled there. So we can't go into -1. And we can't step into the water on this side. So we can't go on to 6. So there's 2 out of bounds conditions here. So I've just redrawn the same scenario. We can't go in 6. We can't go in -1. What happens if we try to step into number 5 right here? So can we step on a 5? Can I step on this lily pad right here? If I was on 4, can I step on 5? So if I'm on 4 and I want to step on 5, the value next box is 5. So let's look at the math on that. We're going to run the same function again, but this time the box we're trying to step on is a 5. So as a reminder, I'll change the color. We're going to be trying to step on the number 5. So if I try to step on 5 and my next box is 5, and the size of my playing field is 6, the first thing that happens is it's going to say, is 5 less than 0? So, I'm sorry, you didn't see what I just did? I didn't have my screen up. Let me bring it back to you. All right, so if I want to step on 5, is 5 less than 0? Is 5 less than 0, yes or no? Is 5 less than 0? Okay, I'm gonna pop. So basically, yeah. So on a number line, maybe I should have started with a number line just to make sure everybody has a memory of what that looks like. We've got, for example, we've got negative values such as, we got negative values. We have 0, and then we have positive values, right, on a number line. So if we're over here at 5 is greater than 0. So if we say, is 5 less than 0? That would be false. It's not true. So we're not going to do that line right there. We're going to skip it. Instead, we're going to say take 5 and find me the remainder using 6 as a divisor. So how many times does 6 go into 5? How many times does it go in? Give you some options here. How many times does 6 go into 5? Most people, I'm going to stop sharing the screen for a minute so I can publish these results. So if I publish these results, 10 people came up with the correct answer, which is 0 times. So it's 0. Well, it's not a good color necessarily. Get back into green. So 0. 0 times 6 is 0. So if I take 0 away from 5 take away 0 is, if I start out with 5 and I take nothing away, how many do I still have? I have 5, and that's my remainder. So the value I'm going to return as a remainder, because it's 0 remainder of 5, that's the value I'm going to return. So what I want you to see is that if I try to land on 5, it's going to say land on 5. And the way the math works out, when they go to step on it, they're going to end up in the correct location. So in practice, when you're playing the game, if you go to step on number 5, it is a valid location, and the math will let you land on 5. So you can land on all of these locations, 0, 1, 2, 3, 4, and 5. They all work. But if you go to land on 6, it does something special. And if you go to land on -1, it does something special. And it keeps you from going off into limbo. Make sure I'm showing you the right thing. So you can land here, you can land here, you can land there, because all we're doing is coming back with the exact same thing as a result of our calculation. It's when the algorithm says, the calculation says, I want to step on 6. The math says, well, 6 goes into 6 one time. 1 times 6 is 6, and my remainder is 0. And so 0 is where you get put. So instead of landing on 6, you get teleported all along here, and you're going to end up at position 0, which is over here. The other part of the code that's unique is when you go to land, if you go to move from a 0 to a -1, and that's that other line of code which says, is the next box less than 0? If it's less than 0, we add 6 to it. So we say -1 plus 6 is going to put us on 5. So when you go to step over from here to here, it's going to teleport you to position number 5, which is going to land you right there on 5. So that's how the code works to move you back and forth if you go over the edges. Have you ever seen that in a game before? Is that something you've seen before? Maybe in this game? Now, as agonizing as it might seem to do the simple math between -1 and 6 using a field size of 6, and we just did that with x, it also works with y. And if you do x plus y plus z and you use variables, that's the mechanic that lets you do Portal. So that's the code that lets Portal teleport you around. What questions, thoughts, reactions might you have to that information? So I just showed you how the code works for Portal in a game that you already coded. And it's like 5 lines. It's that little function that you coded from a picture that does that. It's that math right there that lets you teleport around. It's long division using integers. It's understanding a number line. So these are not considered higher level mathematics. These are considered simple mathematics like add, subtract, multiply, and divide. Yes, we're encoding them in C++. Yes, there's a very clever implementation of simple math. That's the beauty of it. It's called eloquence. Something very simple that works. No reactions, no comments. I'm looking for an applaud or a handshake or some kind of an emoji icon, but nobody seems to be fazed by this at all. All right. Because here's what I had to do. I had taught this class for 3 or 4 years using this program, and somebody asked me once, how does it wrap around the screen? And I looked at it and I was really surprised how simple the math was. And I said, this is really a teachable moment because I hadn't thought about how it actually works. So, yeah, it works in, let's see here.
This pattern is called tunnel terror.
So this is called tunnel terror. And if either the player or the ghosts go into the tunnel, they will wrap around the screen. In fact, there's also a slowdown effect that happens on the ghosts when they go in the tunnel. They slow down a little bit on the turns as well. So as each part of the ghost or the player goes into that transition point, the other half starts to appear. It's using the code that we just used, but it's based on a screen size that's a little bit bigger. It's the same math with slightly bigger numbers. And we're doing it with X and Y because this is a 2D game. It's no different than the math that you just worked through with me.
You are now muted.
Can you see the screen okay? Oh.
You are now unmuted.
All right. Hopefully you noticed the companion cubes outside of the space there. I don't know. To me, that was just mind blowing to figure out that this simple math was how Portal works. So, to me, this is a simple game, and the two goals I wanted was to cover how it wraps around the screen, and please ask questions. This is not a simple thing. It's simple math, but it's not simple. And this is not an easy class. It's an interesting class, but it's not an easy class. So please let me know what questions you have about what I just talked about here, how you can teleport if you go to step off of the world using simple math. You can still ask questions, but I do want to share my screen and make sure you understand what I'm asking you to do today. In addition to being forthright on any questions you might have, there's an assignment here. By the way, I've got 25. I've got a couple of more people have turned in their base maze game, but this is an indication how many people have not yet finished the coding for the maze game. 25 people. So it is one of many activities if you're still working on older ones. But this one needs to be done so that I can see people know how to code basically. All right, so check your Tech Campus email, reply to at least one message. This is something you can get done very quickly. Make sure you mark it as done. The other thing on the calendar for today is a worksheet that I walked you through. So in the instructions here, so attach a Google Doc or in your own words, how could you make this work with a larger grid size? All right, and then there's a last answer here. So in this worksheet, it's showing you the code, and I want you to know that if it passes in a 0 and a 6, that it's going to say, you want to land on 0? You land on 0. If you want to land on 1, you're going to land on... So you'd write in the answer there, or at least understand what it is. If they try to land on 2, could they land on 2? Yes. 3, 3. 4, 4. 5, 5. 6, 1. Actually, 0. Sorry. If they try to step on 6, and it's a six size grid, we're going to actually say the remainder is going to be 0, so that's going to move them to 0. I almost got that one wrong. And -1, that's the case where we move them to 5. So not just getting the answers right, but understanding how that simple math works and how it wraps you around the screen is what I'm after. So describe how that works in your own words. And how could you do the same thing with an 8x8 instead of a 6x6? I'm going to grab somebody's code who's turned it in, and we're going to turn it into an 8x8 grid. Take a look and see who's turned it in. So that's the other assignment I was on a minute ago. And I did send out sharper images of the code along with links on how to get this turned in case anybody needs it. So let's see here. Alexander, you're in right now, aren't you? Different Alexander. No, you're here. So let me take a look at his code. And first I'm going to run it. And he's got a 6x6. There's the player. There's the target. So if I touch D and hit enter, I should show up here next to the target. So let me try that. D, enter. Now the player's here and the target's there. So if I go R for right, it says congratulations, you won. So he's got it coded properly. So what I'm going to do now is I'm going to make a copy of his code. I forked it, and now I want to get in here and change it. So instead of using 6, I'm using 8. You ready? Private chat message to the student just to make sure I get their okay to use the code. Someone tell me what function the screen wrapping happens in. What function does this? It's a very short function. It's got a really weird name. It's the mod one. It's the modulo one. It's all the way down. It's the very last thing you type in. It's the shortest function. It's this one right here. So the MOD is a value we're passing in. It's the measure of that dimension. If I pass an 8 in here, it doesn't care. I can pass in whatever values I want. It's just a variable being set to a value. So next box is going to be the same. It's always going to be the next box. What I want to do here is I want to change it so that it's not always passing in a 6. So here it is right here. All I would need to do is change these two values to an 8, and it would work. But to see that show up on the map, I got to change the print as well. So in the display of the map, I would need to change this to, I'm going up by 2, so I need to go to 9. And I would need to change this one to 8. And if I run it now with those simple changes, my grid is bigger. So now if I count my open spaces, I got 1, 2, 3, 4, 5, 6, 7, 8. It's now an 8 by 1, 2, 3, 4, 5, 6, 7, 8. So by changing values in 4 places, I've made it an 8 by 8 grid. Can I still wrap? Do you think the code will work and I can still wrap? Yes or no? Can I run this with that many changes and still wrap around the screen? Yes or no? If you're not sure, it's okay. I am going to publish these results. Overwhelmingly, you understand that it will work. The only thing that changed is the size. I'm still saying, all right, here's the size of the world. It is going to work. So here's my player, and I'm just going to go right step by step. It'll go over 1, 2, 3, 4, 5. The 6th time it's going to go over here. So let me do 1, 2, 3, 4, 5, 6. Wrapped around. I'm going to go right a couple more, and I'm going to turn around and go left. 1, 2, whoops, my left isn't working. I didn't look at his code to make sure it was supposed to be L. What's going on with my left? I have to do E for exit and get out of here. What am I doing wrong with my L? I got to go to handle player here. Oh, he's got a 1 in there. So Alex, on your code, that's a 1. It needs to be an L. I know it looks like a 1. So I'm going to stop. I'm going to run this again. All right, so there's the player here. And I'm just going to go jump into the L's. There we go. So he can wrap around either left or right, and the code works. So hopefully that makes sense to you. This was a really interesting thing when I discovered this. When I figured out that like 4 lines of code lets you wrap around the screen, and I realized you were doing it here. It works in Pac-Man. It works in Portal. It was really interesting to me to see how simple the math really is. Hopefully it was interesting to you. Oh, you couldn't see my screen. I'll go back in and show you. Sorry. Let me stop this here. I didn't know you couldn't see my code. You guys can have your mics open the whole time, by the way. If I get to a problem where I need to mute anybody, I will. So here on line 104, you would put the number one, and you're copying. Now look at the difference between a one and an L. It's really hard to tell, but L is the key that I want to hit. So let me go ahead and run this version again. Size this up so you can see me. Now the player's here, and I'm going to do L enter, which moved me over one, and then L enter, which moved me over to the last position. And next time I do an L enter, I'm going to wrap around. And I wrapped around properly. So if I touch R and hit enter, I'll go the other way. And I don't know if I'm going to run into a monster if I try to do a wrap around the top, but I can try. Going down, I wrapped around okay. So it works with going down as well. So I've got an 8x8 grid that I can wrap around in either dimension now. Do I have you guys muted? It's like I see comments, but I'm not hearing you guys. I got my volume cranked. That's what I had for you today. I'm going to stick around in case you have questions. I got to get my attendance in, but basically make sure you're on top of those two things. If you're turning in things late, send me a message. Let me know you're turning in late. I want to give you credit. If you do the work, you get the credit. But I'm ready to wrap for the day. So if you got other things to do, let me know. Let me know what I can do to help.
You are now muted.